Now we're going to start by the third video of matrices. We're going to talk about inverse of matrix. Like in multiplication, inverse of 5 is 1 over 5, 7, 1 over 7. So for a matrix A, if determinant is not 0, it has an inverse and it's denoted by A power minus 1. And A power minus 1 times A equal to the identity matrix. And we talked about the identity matrix. It is a square matrix where all the main diagonals are all 1 and everything 0. So we cannot find an inverse of a matrix unless it is a square. So we're going to start by 2 by 2. If you have a 2 by 2 matrix, how do we find the inverse? We do determinant AD minus BC. So 1 over determinant of A, so that's why it cannot be 0, because you cannot divide by 0. What do we do next? We switch A to D, the main diagonal, we switch it, it will be DA, and we put opposite sign of the other diagonal. Okay, so let us take some example. I want to find A inverse and D inverse. So this is a problem, application of problem. So first of all, I find the determinant of A. So minus 6 minus 5 minus 11. So A inverse, it will be 1 over minus 11. So I switch to minus 3, it will be minus 3 and 2. Here I put opposite sign of the second diagonal. So I multiply every entry by minus 1 over 11. So I get this one. For matrix D, same thing, minus 3 plus 2, so minus 1. So D inverse will be minus 1 over minus 1, which is minus. I switch 1 and minus 3, I get minus 3 and 1. And opposite sign here, minus 1 and 2. So I multiply it by minus 1, which was the determinant. So I get 3 minus 2, 1 minus 1. Now, this is a recall of things we did before. Find matrix E so that 2AB minus 3E equal to C. To find matrix 3E, first of all, I need to find the product of AB. This is A times B, 2 by 2 and 2 by 3, so I get 2 by 3. So as we did in the first video for multiplication, I multiply row and column, then row and column, and add. We have this in the first video, you can check it by yourself. So I want to find matrix E, so minus 3E equals C minus 2AB. So this one I multiply it by 2 and I add it to matrix C. So each one I add each entry as we did in the first video. So now I divide it by minus 3, each one by minus 3, I get this answer. This is a recall, we did it in the first video. Find matrix F so that AF minus 2C equal B. The difference between this problem and that problem, matrix E is alone, you don't have a product with other matrix. However, here I have AF. So to find F, it's connected to A. So what do? I take the minus 2C to the other side, I have B plus 2C. This is B plus 2C, this is 2C, you can check. This is the C given, I multiply by 2, okay? So you can take a picture of this one and then follow the problem, this page. I will get this one. Suppose this matrix, I want to name it by alpha. So I have AF equal alpha. To find F, so what do? I need to get rid of A. So I cannot divide it by A as we do in division and multiplication. So I need to multiply. A is to the left. So I put A inverse to the left. I don't put it to the right. Because I have put it to the left, so here in the answer that I have, which is alpha, I must put the inverse to the left. I cannot put it to the right. You know, AB is not BA in matrices. So A inverse, because I need to find F, I must get rid of A by multiplying by A inverse, because A inverse times A is the identity matrix, which is nothing else than 1, so nothing will change. Because I have multiplied to the left, so I must multiply here to the left. As you can see, A inverse times alpha. So A inverse times A is the identity matrix, and identity matrix times F is F. Now I have A inverse. We found up A inverse, as you can see, this is A inverse. So I write it again here. This is A inverse with minus 1 over 11 times matrix alpha. Here I have 2 by 2 and 2 by 3. So I multiply as we did in the first video. I take here the row and here the column, and I do the multiplication, then I divide it by minus 11. In D, find matrix G such that GT equal to A. So I have D now from the other side. So I must multiply by the inverse to the right. Because I multiply to the right, I must multiply here also to the right. You cannot multiply to the left. Right, right, left, left. I need to find the G. I need to get rid of D, so I put D inverse from that side. So this is 2A, this is 2, this is A, this is D inverse that we found up. D inverse here, D inverse that we have found, 3 minus 2, 1 minus 1. As you can see now, I do multiplication, row and column like we did, as I said in the first video. Then you multiply the answer by 2, I get the number. Now I need to solve equation 2 unknown using inverse matrix. So first of all, write the system in matrix equation for. What do we by matrix equation for? I take the components of x and y together, and then I put the variable which are x and y equals 7 minus 7. Why this is correct? Because if you do the multiplication, you take the row and the column here, 2x minus 3y equal to 7, minus 3x plus y equal minus 7. So this is how to write in matrix equation. I solve the system using inverse matrix. So here, this matrix, I name it to be A. So I have A times xy equal matrix 7 minus 7. Because I want to find x and y, I need to get rid of what? Of A inverse. So I must multiply A inverse to the left. So here, not to change anything, I must put it also to the left. I cannot put it to the right. So that's why I said A inverse times 7 minus 7. A inverse, we found it before. This is A inverse. Okay, times 7 minus 7, if you do the calculation, and A inverse A is the identity matrix times xy is xy, and this is A inverse that we found before. Okay, times 7 minus 7, if you do the product here, 7 minus 21 over minus 7 is 2. 21 minus 14, which is 7 over minus 7, it is minus 1. So now we know how to solve a system of equation using augmented matrix that was in video number 2, and we can solve it using inverse matrix. Now we're going to go to 3 by 3. For 3 by 3, we can solve it in two methods. I'm going to start by the first method, then by the second method. The first method, what do? We write the matrix as it is. I put this vertical line. I put its identity 3 by 3. So identity 1 0 0 0 1 0 0 0 1. My aim is this matrix to write it here, and numbers I write it here. So I need to write the identity in place of that one. So what do? We have many calculations here. You must be careful. So I take the first row, it's the fixed one, I copy it again. So here I must put, because I need to write this one here. So here I have 0, here I have 0. So I put here, I must get 0, and here I must get 0. So the first one, I take this with that one. So up by, to cancel, up by 1 and down by minus 2. I have the number here, 2 minus 1, 3, 1, 0, 0. Minus 2, 4, minus 2, 0, minus 2, 0. If you add, you get what? 0, 3, 1, as you can see, 1, minus 2, 0. Now here you have minus 2 and 2. Simply no need to multiply, you add because it cancels each other. 2 minus 2, 0, minus 1 plus 2 is 1, 3 plus 1 is 4, 1 plus 0 is 0, 0 plus 0. So here the vertical line, sorry. 0 plus 0 is 0, 0 plus 1 is 1. Now what do? We take this one to be the fixed one, because here you have 0 in the second one. So here I must get a 0, here I must get a 0. Let us go to the second slide. Sorry, this is the slide. So as I said, this is the same. I copy it here again. So here the 0, here I must have, because 0 0, I must have here a 0, and here 0, and this is the fixed one. So here I have a 3 and minus 1, so I multiply up by 3, down by 1. So let us start. If you multiply, I'm going to do it directly. 3 times 2, 6. 6 plus 0 is 6. 3 times minus 1 minus 3 plus 3 is 0. 3 times 3 is 9 plus 1 is 10. 3 times 1 is 3 plus 1 is 4. 3 times 0 minus 2 is minus 2. Here 0, 0. Certainly we copy this middle one because this is the fixed one as it is. Now here I must get a 0. Here I have a 3. Here I have 1. So I multiply down by minus 3 and up by 1 to cancel. I compare this one to that one. So 0 and 0, 0. As you can see here. 3 minus 3 it is 0. Now I have 1 minus 12 minus 11. 1 minus 3 minus 2. Minus 2 plus 0 minus 2, and 0 minus 3 minus 3. So as you can see here, I have two zeros. Here I have 0. Remain the last one. So I take the last row, which is the fixed one. As you can see here 0. I must get here 0, here 0. So I start. Here I have minus 11. Here I have 10. So I multiply up by 11, down by 10. So 66 plus, I copy the third one, which is the fixed one. 66 plus 0 is 66. 0 and 0 here is 0. 110 minus 110 is 0. 44 minus 20 is 24. Minus 22 minus 20 minus 42. 0 and minus 30 minus 30. Now here I have minus 11. Here I have 1, so I multiply up by 11, down by 1 to cancel, and then I write the second row. So 0, 0, 0, 33 plus 0, 33. 11 minus 11, this is, as you can see, 11 minus 11. This is, sorry, by mistake, this is 0. Now 11 minus 2 is 9. Minus 22 minus 2 minus 24. 0 minus 3 is minus 3. Now, as you can see, I have a diagonal matrix. So to get here 1, 1, 1, I divide the first row all by 66. So here, the second row by 33, I get here. The last row by minus 11, I get this one, and this is the simplification. This is the inverse matrix. There is another method. So another method without doing all of these calculations. So what do? We find first of all determinant. You know the determinant, you put plus, minus, plus 2. In the second video you can check. The determinant is minus 11. So what do we do now? We take minus 2 with 1, 2 with 2. Listen, you do its determinant. Then 1 with 1, so this one, this is the fixed one, this wall, let us say this wall, minus 2 with 1, 2 with 1, we do its determinant, then 1 with 1 and minus 2 with 1. So remains what? 1 with minus 2 and minus 2 with 2. So I have this determinant. Then I take minus 1 with 3 and 2 by 1. So I take the second row with the third row. Then the first with the third. Minus 1 with the 3, 2 with the 1. I do the determinant. 2 with the 3, minus 2 to 1. I do the determinant. Then minus 1 with 3 and 2 by 1. Minus, sorry, 2 by minus 1, minus 2 by 2. So let me repeat from beginning. Minus 2, 1, 2, 1. 1, 1, minus 2, 1. Minus 2, 1, 2, 2. Then minus 1, 3, 2, 1. Then 2, 3 minus 2, 1. You can see it here. Then the last one that we take 2 minus 1 with minus 2, 2. Then the last one I take the first one with the second one. Minus 1 because we took first, second with third. First with third. Now first with second. Minus 1 with 3. Minus 2 with 1. 2 and 3 and 1 and 1, we do the determinant, and the last one 2 minus 1 and 1 minus 2. We have this determinant. So what do we do now? We write these numbers minus 4, 3, 2, minus 2, not horizontally, we write it vertically. Minus 4, 3, minus 2, minus 7, 8, 2, 5, minus 1, minus 3. Then we put a matrix plus, minus, plus, opposite sign, minus, plus, minus, then a plus, minus, plus. So we multiply. Minus 4 times the plus is minus 4, minus 7 times minus is plus 7, 5 times the plus is 5, here minus 3, here a holds, minus 1 times minus 1, 1, minus 2 times plus is minus 2, 2 times minus 1, minus 2, minus 3 times the plus, minus 3. And to finish, this is called a matrix transpose. This is called matrix transpose of all of that operation. Then I multiply it by 1 over determinant. So if you multiply by 1 over determinant, you're going to get the same answer. Look at this one, and the one we did it up, it's the same as you can see. Okay, now I have an application problem. We're reaching the end. So here, given I have these matrices, I need to find B inverse. I have two methods, as I'm going to repeat. If you didn't understand before, we're going to repeat it here. So I take this one, I put its identity because 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So I take this one to be the fixed one. So here I must get a 0 because here I have 0, here 0. So 2 minus 1, I multiply down by 2 and up by 1. So I write the first one. So here minus 2 plus 2, 0. 4 plus 1 is 5. 6 plus 1 is 7. 0 plus 1 is 1. 2 plus 0 is 2. 0 and 0, 0. Here I have 1 and 2. I multiply down by minus 2 and up by 1. Minus 2 plus 2 is 0. Minus 2 plus 1 is minus 1. Minus 2 plus 1 is minus 1. 0 plus 1 is 1. 0 and 0 is 0. Minus 2 and 0 is minus 2. Then I take the middle one to be the fixed one. So I copy the middle one. So here I must have 0, here I must have 0. So I multiply up by minus 5 here by 1. So minus 10 plus 0 minus 10. Minus 5 plus 5 is 0. Minus 5 plus 7 is 2. Minus 5 plus 1 is minus 4. 0 and 2 is 2. 0 and 0, 0. Here 5 minus 1, I multiply down by 5 and this one by 1. 0. 5 minus 5 is 0. 7 minus 5 is 2. 1 plus 5 is 6. 2 plus 0 is 0. 0 minus 10 is minus 10. Now I take the third one to be the fixed one, as you can see. Here I must have 0. Here I must have 0. So 2 and 2 subtract directly. Minus 10, you can up minus below or below minus up. And I did it below minus up. 0 minus minus 10 is 10. 0 minus 0. 2 minus 2 is 0. 6 plus 4 is 10. 2 minus 2 is 0. Minus 10 minus 0 is minus 10. Here I have 7. Here I have 2. I multiply up by 2 and down by minus 7. 0 and 0, 0. As you can see here. 10 and 0, it's 10. 14 minus 14 is 0. 2 and minus 42 is minus 40. 4 and minus 14 minus 10. 0 and plus 70 is 70. Now I divide all by 10 up. I divide all by 10 here, all by 2 here, and this is B inverse. This is method 1, or you can do it in method 2, the transpose 4. Let us see it. So you do first of all determinant. You can check its determinant is minus 1. So this is the method 2. Okay, determinant is minus 1. So I write 2, 3, 1, 1 determinant, then minus 1, 3, 1, 1, then 2, 3, sorry, minus 1, let me repeat, 2, 3, 1, 1, minus 1, 3, 1, 1, then minus 1, 2, 1, 1. Then 1, 1 with 1, 1, 2 with 1, 1 by 1, then 2, 1 and 1, 1, as you can see. And the last one will be 1, 1 with 2, 3, 2, 1 with minus 1, 3, and 2, 1 with minus 1, 2. The last one, the 2, 1 with minus 1, 2. Okay, so 1, 1, 2, 3, I have it here. Then 2, 1 with minus 1, 3, because I found something wrong. And the last one will be 2, 1 and minus 1, 2. Okay, so here I have something wrong. Let me see. 1 with 1, 2 with 3, 2 with 1, minus 1 with 3, and the last one 2 with 1, sorry, minus 1 till 2, correct. So this was wrong, so it will be 4 plus 1, this is 5. Okay, this was wrong. So I write it in minus 1, minus 4, minus 3, 0, 1, 1, and 1, 7, here 5. Now, what do? I put as I did before, plus, minus, plus, minus, plus, minus, plus, minus, plus. So minus 1, 0, 1, 4, 1, minus 7, minus 3, minus 1, and 5. Okay, 5. Here I have 5. I multiply it by minus, what do I get? 1, 0, minus 1, minus 4, minus 1, 7, 3, 1, minus 5. So this is the inverse matrix. Let me check it with the one I did it up. So as you can see, 1, 0, minus 1, then minus 4, minus 1, 7, 3, 1, minus 5, 3, 1, minus 5, 3, 1, minus 5, the same answer. Now in part B, find matrix C given CB as we did in 2 by 2, same story. The B here I need to get rid of, so I multiply by B inverse to the left, to the right. Not to change anything, I must multiply to the right. So B inverse is the identity matrix, so C equal to A, this is A, and the B matrix that we found now. I do the multiplication like we did in the first video, I get this one. Find matrix D given that BD is A. So I need to find D, so I need to get rid of B. I multiply to the extreme left, here also to the extreme left. So D will be B inverse A. I do the same thing here, you can do it by yourself. And the last page, write above system in matrix equation. This is the system, so 2 minus 1, 1, 1, 2, 1. 1, 3, 1, 3, 4, 2 times the XYZ matrix equation equal 3, 4, 2. This is how you can write a system in matrix form equation. Solve the above system using matrix. This is B. This is B given to be matrix B that we found its inverse before. This was B 2, 1, 1 minus 1, 2, 3, 1, 1, 1. So it's already B. So I need to get rid of this B to find XYZ. I multiply by B inverse to the extreme left. Here I write on that side to the extreme left. So XYZ, okay. So B inverse B, you cancel B inverse B, remains XYZ. So this XYZ will be, so this cancel. It will be B inverse times 3, 4, 2. This is B inverse times 3, 4, 2. So I multiply. 3 plus 0 minus 2 is 1, minus 12 minus 4 plus 14 is minus 2, and 9 plus 4 minus 10 is a 3. So matrix was done in 3 videos. I think everything must be clear, and see you in class.